Yes, hi friends. We are going to learn another algorithms based on brute force technique. In previous class, we already discussed what is brute force technique, and we have learned what is a selection sort, right? And about sequential search, we have learned already in the previous chapters under performance analysis. So this part is also been completed. So now we are going to focus on string matching algorithms with complexity. Remember that when you are saying the string matching, some person used to say that pattern matching. What will happen in this? We are going to find a particular pattern in the given text, main strings, right? Say as per example, Bangalore is very good city, and we wanted to find out good pattern as a good, whether good is present or not, right? So that is what our programs will give you the outcome, that pattern is found or not found. So basically this algorithm technique is also called brute force pattern matching technique. This string matching algorithm is also called brute force pattern matching algorithms, right? Because you are applying direct brute force, straightforward approach. Or this is also called Naive pattern matching algorithm. Naive pattern matching algorithm. Okay, because Naive is a mathematician, he has given that concept of pattern matching, right? Hence it is called Naive pattern matching algorithms. Now we are going to learn how basically this algorithm works. Say as for example, a very simple input is ADA is only the subject. ADA is only the subject, right? So this is a main strings. So we'll call it as a text. Right? This is the text. Now we should have the pattern strings which is present or not present in this, both the cases. So say we are going to find out pattern as a DA, right? Whether DA is present in this or not. By seeing this example from our open eyes, we can see that yes, DA is present, right? But how exactly your program works? Okay, how you are going to think, right? And your program should give you the proper outcomes. Okay, DA is present. Where it is present? Remember that first, since it is a string, and string is also called set of character. So this is a kind of character array. So we are going to write the index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have written that array index, and array index is from 0 to 18. It means what? Size of that string or length of that string is 19. Similarly, pattern index is 0, 1, 2. Right? Remember that each and every pattern end with null character. Each and every strings end with null character. So at the beginning, when you are thinking of writing this program, right? First we are going to find out the length of text, length of pattern. So we are going to find out length of text. Basically it will give you that number of character present in that particular strings. So main string is a text. So here is length is 19. Similarly, length of pattern. We are going to calculate and found it is 3 character is present in pattern DA. So in a program, when you're writing it, we can use even inbuilt functions, right? String.h header file, and we can find out strlen string length of text, string length of pattern. What is very much important is to read this input in the form of character, right? So first is a set of character here as a text string, then we have a pattern, and finally we are going to find out whether given pattern is present or not. So let us see how it will go. We are going to compare this D and A. What brute force technique says that you perform the task from left to right. So if you are going to perform the task, whether A and D is the same. Look, pattern of 0 is D, text of 0 is A. Whether A and D is the same? No, it is not same. If it is not same, in that case, we are going to shift, right? Means next time you are not going to compare D with A. Next time you are going to compare D with D. Got the point? D with D. Right? So here, in this particular case, D and D is matching. So generally what will happen in book, they are shifting the pattern toward right such a way that you can easily compare. So in that case what will happen here? D and D is matching. Hence, pointer of both text and pattern will increase, right? Then we are seeing that A and A is also matching. Again, pointer will increase. Now we are looking for text of 3 and pattern of 2 is matching. Underscore and A is not matching. If it is not matching, it means what? Again, we have not in a position to find the text. So we'll go and shift little right. Previous case we have compared D and D first. Now this will go D and A first, right? And we are going to perform the task again and again, and finally we will get the answer. So let us see that. Let us try to learn how exactly it will work. ADA is only da. Okay, here we have a da. Look, 0, 1, 2, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. No, we are comparing this and this. It is not matching. So now da we have shifted here, right? Now we are comparing D and D. Is it matching? Yes. Then pointer will increase. A and A is matching? Yes. Pointer will increase. Underscore and A is matching? No. If it is not matching, again pattern will shift towards right. Now we are going to compare here A with D. A with D is matching? No, it's not matching. Not matching means pattern will shift towards right. Is da and underscore is matching? No, not matching. So again we are shifting towards right. Look here, we are talking about I and D. Is it matching? No, it's not matching. So again we are shifting towards right. Is it S and D is matching? No, it's not matching. So again we are shifting towards right. Look, underscore and D, is it matching? No, pattern is shift towards right. D and O is matching? No. Similarly, what will happen? Pattern will shift towards right. So next is what? DAA, is it matching? No, pattern will shift towards right. DAA is matching? No, pattern shift towards right. DAA is, sorry, D and Y is matching? No, pattern will shift towards right. Underscore and D is matching? No, pattern will shift towards right. Once we are done with right, we can see that Is D and D is matching? Yes. Next, A and A is matching? Yes. A and A is matching? Yes. And we can see that now we encounter with null character. Hence, length of the pattern was 3 and 3 character is already matched. Hence, this die is already present in the given text. Now, where this die is present? Where this die is present in the given text? Look, I position is 12. So, our output should be from 12. Position is array index 12. But real life position is not start from 0, it start from 1. So, we are going to add 1, 12 plus 1 is 13th positions, die is found, that pattern is found in the given text. What is the last value of text here? Is 14, right? It means our initial value was 14 minus 3. From thereafter, after 11 means 12 positions only we are getting the proper values. Look, even there is another input, right? Die is 3-letter word. And after shifting, say here die is not present, here something else is there, but we need to go and compare. Keep on you are going and comparing it, and we reach to that second last positions or lesser than the length of the pattern. So length of the pattern is 3, but we need to compare with last 2 elements. Will you get that pattern? No. Hence, we can apply the concept, right, such a way that it will take lesser amount of time. So number of characters present at the last should be more than, right, or equal to the length of the pattern. Then only we can find out the answer. So based on this, we are going to write the code. If you remember that, friend, how we have proceeded? We have shifted from left to right, and when we are shifting the pattern. It means what? Pattern pointer we are increasing. Hence, we are comparing with the text values, right? And we are going to perform again and again until unless, see here, index was 0, index was 1, index is 2. Once you are done with that, next index of pattern is 3. So once we reach to that pattern 3, then only we can say that pattern is found. Otherwise, pattern is not found in the given, text string. So let us see how you are going to write it. Say here we have pattern match. What are the thing is required, friend? Is char text string, right, and char pattern string. Both are character type. And here we have what? N is equal to string length of text and M is equal to string length of pattern. String length of text, string length of pattern. As I said at the beginning, we require both the length. Once we're done with that, we can see that we started with left hand side, I pointer increases, and what will be the position of I? Let us see that. For I is equal to 0, I less than equal to n minus m, I plus plus. Okay, I is equal to 0, I less than n minus m. N is length of text, m is length of pattern. So this I value will be maximum of n minus m. As I said you that at last, if you have lesser number of character compared to the pattern, there is no meaning of going and comparing it because we will not get the pattern. Done. Under this, we are just initializing j is equal to 0, starting values. And what we did, friend? We have done comparisons. What is that? J is less than m. If j pointer is lesser than m and j less than m and T, just I'm writing text, okay, T, text of I plus j is equal to pattern of j. Always please concentrate here. While j less than m, j pointer must be lesser than m, and text of I plus j is equal to pattern of j. Okay. If this both the condition is true, condition j less than m, condition second is text of I plus j is equal to pattern of j, then j will increase. J plus plus, j will increase. And we have seen that if pattern is matching, we increase the pointer. Pattern is matching, we increase the pointer. In this case, D and D was matching, we are increasing the pointer. Let us see these scenarios. Okay, first T, it was T of I is here 0 and j is also 0 is equal to P of 0. If both are equal, then increase the j. If both are equal, then increase the j. So both are not equal, then we will go and increase the value of I. Got the point? Yes. So j will increase. A moment we are saying that j is increasing, right? In that case, we can find that overall values of I and j is also increasing it. So let us see. J will increase. There will be scenario where j reach to value of j is not less than m. J becomes m. We can see that pattern da 0, 1, 2 is increased and becomes j pointer becomes 3. And I said you stop here. Pattern is found. So similarly, if j is equal to m, pattern is found. So these things we need to repeat again and again. And if you are getting the situations where if j is equal to m, right? Then we can say that return I plus 1, else return minus 1. Why I plus 1 minus 1? Because if j is equal to m, pattern found, and as I said you in the previous example, pattern found at position I index is 12. And what I said, it is not real life counting. Real life position is 12 plus 1, 13. So that is why I just mention here is return I plus 1, and this will send to the main functions that pattern is found at positions 12 plus 1, 13. Suppose in a given example we don't have proper pattern, it's not present. In that case, maybe we are not going to encounter with these scenarios, right? Hence value of j will be lesser than m because pattern is not found. In that case, it will be returned minus 1. Hence, we can say that that particular pattern is not present in the given text, right? Similarly, we can have examples and you can try by yourself, right? Any examples like and say we are going to find out uncle in this. So this is the text, this one is a pattern, and we can search it whether pattern is found or not found, right? Now we are going to discuss time complexity. Time complexity for pattern matching, right? Remember that again we have used the loop concept, hence it is not a recursive function, it is a non-recursive algorithms. So we are going to write T of n is equal to summation of I start from 0, and what was the last value of I? N minus m, n minus m. Similarly, j start from 0, and what was the last value of j? j was m minus 1. J was m minus 1. Till m minus 1 we are going to repeat it, otherwise we are terminating that statements. And here we have basic operations 1, where we are going to do the comparisons t of ij, t of I plus j is equal to p of j, pattern of j, right? Simplify this, upper limit minus lower limit plus 1. So we are going to write I is equal to 0, n minus m, upper limit m minus 1 minus 0 plus 1, 1 and minus 1 got cancelled, hence we are getting it I is equal to 0, I less than n minus, okay, and of m. Now we can see that, friend, this m is independent from I, so m you take it out, as we discussed in the previous examples. I is equal to 0, n minus m, and m you have taken as a common. Now what is left here? Here is left is 1. Again we do that same concept, upper limit minus lower limit plus 1. So n minus m, upper limit minus lower limit is 0 plus 1. And we can see that we are getting n minus m plus 1. We will simplify this, we are getting mn minus m square plus m. Look, this is very important. Once person is saying that this is the time complexity, right? T of n is equal to mn minus m square plus m. Now, which is greater? Whether mn is greater or m square is greater? People used to say that m square is greater because it is quadratic. No. When we are discussing that, what I said, m is length of pattern. M is length of pattern. And what is the length of text? Length of text was n. So length of text will be always greater, right? Length of text will be always greater than m. Then only we can say that pattern is formed, right? So n must be greater than or equal to m. In that case, if m is having lesser values, say as for example, n is having 10 character and length of the pattern is 3. So mn, if you are talking about mn is 30, while m square is 9. So we can see that mn value is greater than the m square values. In that case, we can say that time complexity of pattern matching algorithm is theta of mn. Theta of mn, where m is length of the pattern, n is length of the text, right? Apart from this, you are having different algorithm you can practice by your own, right? Those are not in this particular chapter. Is KMP, pattern matching algorithms. There is a Robin-Karp, pattern matching algorithms. We have a Horspool, pattern matching algorithms. We have a Boyer-Moore, pattern matching algorithms, and we have a finite automata, pattern matching algorithms. Yeah, finite automata, pattern matching algorithms. So these many algorithms we have, right, for finding the proper pattern in the given text. Done. KMP, Robin-Karp, Horspool, Boyer-Moore, finite automata, pattern matching algorithms. So these all algorithms you can go through it when you are getting time, right? All are very important, and these algorithms used to take lesser amount of time if you compare with brute force pattern matching algorithms what we have learned it, right? Hence today we have done with the brute force technique, pattern matching algorithms, and their time complexity. As you know that time complexity of pattern matching algorithm is theta of mn. Yeah, theta of mn. Very important. Then now question is, when will be the best case of pattern matching? When will be the best case of pattern matching? When you are saying that best case of pattern matching, when pattern found at the beginning. Pattern found at beginning. In that case, time complexity is theta of m. Best case is theta of m when pattern is found at the very first place onwards, first positions. Time complexity will be theta of m. Otherwise, theta of mn. Thank you very much.